Yes, children. Yesterday we saw about intensive and extensive properties. Okay. So in continuation with the chapter, let us see now how a change of state of a system can take place. Okay. Change of state can occur through a process. Now, what are the different processes which can change the state of a system? They are isothermal process, which is conducted at constant temperature. Adiabatic process. Adiabatic process means heat can neither flow from the system nor to the system. Heat can flow from the system to the surrounding and neither. Heat can neither flow from the system to the surrounding and vice versa. Both of them is not possible. Okay. That means the system is insulated from the surroundings. That is what you call it as an adiabatic wall. Okay. Heat can neither go into the system nor can come out of the system. It is something like your thermos flask. Okay. Then isochoric process, which is done when volume is kept constant. Isobaric process, where pressure is kept constant. And then reversible and irreversible process. Reversible process means that is any reaction which can be reverted back. And irreversible process means any reaction that is taking place only in one direction. It cannot be reverted back. Okay, that is called as a irreversible process. Okay, now I have given certain examples for this through animation video. Just go through it. Okay, I suppose you will understand that better, right? Okay, now let us come to thermodynamic quantities. Now, what are thermodynamic quantities? Internal energy is one such thermodynamic quantity. Now, what is internal energy? Energy possessed by the system is called internal energy. Like, what is the energy that you possess? Okay, what I possess. It is all internal energy. Can you measure internal energy? No, you cannot measure internal energy. Then what can you measure? You can only measure change in internal energy. Is that clear? Now that's what we are going to see. Now say for example a glass of water. Now that is my system. Now the sum of energy associated with the molecules of water, whatever energy that is associated, that is say movement of molecules, that is kinetic energy, then thermal energy, then rotational energy, potential energy, and all other types of energy that is put together is called internal energy of that system. Okay, and this internal energy, it is a state function. What we have seen about state function depends only upon initial and final states of the system and not on the path followed to reach that state. That is called as state function. Okay. And you cannot measure internal energy, but a change in internal energy can always be measured. Okay. Now let us see how. Say for example, a system is there whose internal energy, it is assumed to be U1. And the final internal energy after doing either work is done on it or the system itself is doing some work, final internal energy is U2. Neither do you know U1 nor do you know U2. But then as the state function suggests that it is the difference between final and initial. So what is change in internal energy? That is equal to U2 minus U1. U1 was initial and U2 was final, is it not? U2 minus U1 is delta U. Now this internal energy change, how can it take place? It can take place when heat passes into the system or it is coming out of the system. Same way, either work is done on the system or by the system, or matter is entering the system or leaving the system. In any of these ways, there can be change in internal energy that can occur in a system. Right. Now, for example, let us change the internal energy of a system by doing some adiabatic work. Adiabatic work. What I told you, adiabatic work, that it is having insulation around it. So heat can neither go into the system nor can it come out of the system. Something like thermos is considered to be adiabatic system. Okay. Now let us do work on it. Say for example, you are having water taken in a beaker and that is insulated from the surrounding. Okay, this is what I told you, adiabatic wall. Now you can change the internal energy of that water that is taken in the beaker. How can you change? Either by doing mechanical work on it or by doing some electrical work on it. Is that clear? दोनों तरफ से हम उसकी internal energy को बदल सकते हैं. How can you do that? Say for example, you are keeping a set of paddles inside the beaker. And then just like हम बटर मिल्क को churn करते हैं ना मक्खन निकालने के लिए, something like that, a set of paddles is set inside the beaker and only the handle is outside. Now through the handle you are just rotating it. So the water inside, it is getting mixed up, is it not? It is getting agitated. Now because of this agitation, what happens? Temperature of water rises. Now the amount of work, the churning that you are doing or the rotation of paddle wheel that you are doing, it is worth say 1 kilojoule. Okay, and it increases the temperature of water from T1 to T2. Okay, either you can do like this, or what you can do, electrical work means you can put an immersion rod inside the beaker, okay, and you switch it on and the water inside the beaker, the temperature is increasing, and that is also equivalent to 1 kilojoule. Okay, तो ये समझ के कर लेना. Now the rise in temperature of water, in both the cases you are going to keep it as, you are going to understand that it is going to be the same, because the same 1 kilojoule of work is done on it, either mechanically or electrically. So the rise in temperature is from T1 to T2. Okay, and it has produced the same change in internal energy in that system. And delta U is equal to W2 minus W1, you know it. And what is this? How this change has happened? Because of the work that you have done on it. What is that? It is adiabatic work. That is W adiabatic. AD means adiabatic. Okay. Now if you find that delta U is positive, that means the system has absorbed energy. And if delta U is negative, that means the system has released energy. And remember one thing, W, work done, is positive when work is done on the system. These are by conventions. By convention, work done on the system is considered positive and work done by the system is considered negative. Okay, if the system is doing work, it is spending some of its energy, तो खुद की energy थोड़ी सी कम होगी, is it not? So final energy will be less than initial energy. So what is the difference? Difference will be negative. Whereas if work is done on the system, then the system gains energy. So final minus initial will be positive. That is why we use this conversion. Work done on the system is positive. Work done by the system is negative. Okay. Now here this delta U is nothing but work done adiabatic. Right? Okay. Now this internal energy, it is an extensive property. Right? Why? Because it depends on the quantity of substance that is present in the system. Is that clear? Extensive means dependent on mass. Intensive means independent of mass. Right? Okay. Now, internal energy of an ideal gas, if you consider, it has been found to be a function of temperature. Now supposing if you take an isothermal process, iso means same as, thermal, that means same temperature, okay, where temperature is constant, that is called as an isothermal process. There is no change in internal energy, that is delta U is equal to 0. How it is equal to 0? because you know that delta U is equal to W adiabatic. Now, when temperature is kept constant, there is no work done on the system. So work done, if it is 0, then delta U is also equal to 0. Okay. If you are maintaining constant temperature, the system, say for example a gas, it is neither expanding nor contracting, nothing is done on it. So work done is 0. In that case, delta U will be W adiabatic. Now this change in internal energy can also be brought about by transfer of heat. How it can be brought about by transfer of heat, right? Let us see. Now, say this is a system, okay? I have placed the system inside a big trough, मान लो, ठीक है? And that trough contains hot water, and the system is a simple beaker which is kept closed, okay? And Q joules of heat, the surrounding area, it is supplying Q joules of heat into the system. So the system is absorbing heat from the surrounding through a thermally conducting wall. Is that clear? It is not adiabatic. So heat from outside can get inside. So it is absorbing heat from the surrounding through a conducting wall. It is a thermally conducting wall. Okay. Now, since it is a conducting wall, automatically heat from where it is, it will go to that area where it is less. The movement of heat. You have studied about convection, conduction and all that, right? So here, automatically heat will get transferred from surrounding into the system. Have you done any work? You have not done any work. Okay. Now here, what is delta U? Delta U is nothing but Q. What is Q? Q is the amount of energy, or Q joules of heat is absorbed by the system, but without you and me doing any work. So work done is 0 here. So in that case, what is this delta U? Change in internal energy is nothing but heat absorbed by the system. So you say delta U is equal to Q. So what we saw initially, delta U could be W also, and delta U could be Q also. Okay. Same way, convention is used in the case of Q also. Q is positive when system is absorbing heat, and Q is negative when the system is releasing heat to the surrounding. Okay. So both W and Q are in terms of system. The system is doing work. It is spending some energy. So it will be negative. Now something is done on the system, then W is positive. Same way, the system is absorbing heat, Q is positive, and taking in is positive. Giving out, that is negative. Okay?